Hi everyone! Today we're going to be doing something a little bit different from what we usually do. We're going to be solving this algebraic problem including exponents. So if you'd like to, you can go ahead and try to do this problem on your own and then come back to the video where we're going to be discussing a step-by-step solution on how to actually solve the equation. So now let's get started on how we are going to solve this question. So, first of all, let's simplify the equation. This is 3 raised to the power x squared plus 9 raised to the power x squared gives us 27 raised to the power x squared. So we'll keep the 3 raised to the power x squared the same. Then 9 can also be written as 3 squared. So 3 squared raised to the power x squared gives us 27 can also be written as 3 cubed. So 3 cubed raised to the power x squared. So if you're familiar with exponents, then you would know that there is a rule which states that a raised to the power m raised to the power n is the same thing as a raised to the power mn, which is also the same thing as a raised to the power n raised to the power m. So we're going to be using this rule on the second term and this term. So we're going to write out the equation as 3 raised to the power x squared plus 3 raised to the power 2 times x squared, which gives us 3 raised to the power 3 times x squared. So we're going to simplify the equation and write it as 3 raised to the power x squared plus 3x squared raised to the power 2, which gives us 3 raised to the power x squared raised to the power 3. So we're going to write this. So if you notice, and if you look closely, then you'd see that there is 3 raised to the power x squared in all of these terms. So what we're going to do, we're going to assume that, let us say that 3 raised to the power x squared is equals to t. So we'll replace 3 raised to the power x squared with t. So that would give us t plus t squared, which gives us t cubed. So now we have a fairly simple equation, and let's go ahead and solve that. So we have t cubed minus t squared minus t, which gives us 0. So let's get closer down to the actual equation, and let's take t as a common. So this would give us t squared minus t minus 1, which gives us 0. So we can go ahead and say that t is equals to 0, because if t was 0, then 0 times anything, well, really, gives us 0. But is that possible? No, not really, because if you look closely, this is 3 squared. Oh my god. No, not really. Because if you look closely, well, t is equals to 3 raised to the power x raised to the power 2, which is also equals to 0. But no matter what you raise x to, x squared would give us a positive integer. That means t would equals to 3 raised to a positive integer. And anything 3 raised to the power raised to any positive integer would never give us 0. So that means t is equals to 0 is not a possible answer. So let's look closely at what else it could be then. Well, our equation is t times t squared minus t minus 1, which gives us 0. But now if you look at it, and you'd see that this is a quadratic equation. So that means it is in the form of ax squared plus bx plus c. And to solve any of these equations, we would use the formula minus b plus minus the square root of b squared minus 4ac divided by 2a. So if we plug in the values for that equation, we'd have minus 1 plus minus 1 squared minus 4 times 1 times negative 1 divided by 2 times 1. So simplifying this, we'd have 1 plus minus 1 plus 4 divided by 2, which gives us 1 plus minus the square root of 5 divided by 2. So we have our value of t, which is 1 plus minus the square root of 5 divided by 2. Now let's look closely again. The square root of 5 is, well, obviously bigger than 1. So if we subtracted anything bigger than 1 from 1, that would result in a negative integer. That means if we subtracted the values of t are 1 plus the square root of 5 divided by 2 and 1 minus the square root of 5 divided by 2. We are looking at this possible answer, and if we subtracted the square root of 5 from 1, that would result in a negative integer. And t is not a negative integer because a number raised to a positive integer can never be a negative integer unless the number itself is negative, which in this case is not. So we have our value of t, which is 1 plus the square root of 5 divided by 2. So what do we know from this? Well, we know a couple things. 3 raised to the power x raised to the power 2 is equals to 1 plus the square root of 5 divided by 2. So now what we're going to do is we are going to use some logarithmic rules. So we are going to take the log of 3 raised to the power x squared, which gives us a log of 1 plus the square root of 5 divided by 2. So if you are familiar with log, then you would know that there is a rule which states that log m raised to the power n is the same thing as n log m, which means n times log m. So we are going to be using this rule on this term. So we're going to rewrite this as x squared log 3, which gives us log 1 plus the square root of 5 divided by 2. And now we're going to divide both sides by log 3, which would give us x squared is equals to log 1 plus square root of 5 divided by 2 divided by log 3. And now we're going to get rid of this squared sign. So we're going to take the square root of both sides. So we would have square root of log 1 plus root 5 divided by 2 divided by log 3. And this would obviously be x plus minus. So now we have our answer. Our answer is x is equals to plus minus log, the log of 1 plus root 5 divided by 2 divided by log 3 and the square root of that. So this is our final answer. So thank you for watching this video, and I hope that you're walking away with a little bit more knowledge about, well, this question. So thanks for watching, and be sure to like and subscribe.